Okay, we have one more example in section 3.5. We're graphing rational functions using a 7-step process outlined on the screen. We find the asymptotes and we find the intercepts. We check if the graph crosses the horizontal or oblique asymptote, and we make a sign diagram. And then we can put all that together to sketch the graph. So let's go ahead and get right into it. The first thing that we need to do is we need to factor the function, and we need to make sure that it's in lowest terms. So the numerator factors to x times x plus 1, and the denominator remains x minus 1. And so that's already in lowest terms. And so in order to find the vertical asymptote, we set the denominator equal to 0, and the vertical asymptote is at x equal 1. In order to find the horizontal asymptote, we check the degree of the numerator and denominator. Since the degree of the numerator is exactly 1 more than the degree of the denominator, 2 versus 1, then there is no horizontal asymptote, but there is an oblique asymptote. And in order to find the equation of the oblique asymptote, we're going to use synthetic division. And so, just like in section 3.2, we're going to take the coefficients of the numerator and list them out underneath the division sign. So we're going to have 1 times x squared plus 1 times x, and don't forget to add a constant 0 at the end. And then in the denominator we have x minus 1, so we take the minus 1, we change the sign, and make it a positive 1 out in front of the division symbol. And then we can go ahead and go through the division. We've got 1, 1, 2, 2, 2. And the last number there represents the remainder, and the numbers in front of it represent the quotient. And what we learned in the previous video is that the oblique asymptote, the equation of the oblique asymptote, I'm going to abbreviate that OA for short. The equation of the oblique asymptote is y equals the quotient. So the quotient is 1 times x to the first power plus 2. And so there is an oblique asymptote. Okay, we can go on to find the y-intercept. We can just set x equal to 0. H of 0 is equal to, let's see, the numerator will be 0, and the denominator is negative 1. And so we just have 0. So the y-intercept is at 0, 0. That would have to be an x-intercept also, since it's intersecting the x-axis also. So we'll see that in just a second. We'll find the x-intercepts. In order to do that, we learned to set the numerator equal to 0. If we start with the factored form, x times x plus 1 equals 0, then x equals 0, or x plus 1 equals 0, which gives x equal negative 1. So we have 2 x-intercepts. We have an x-intercept at 0, 0, and we have an x-intercept at negative 1, 0. Okay, we want to know if h of x crosses the oblique asymptote. And so in order to do that, we're going to take the function and set it equal to the oblique asymptote. So the function is x squared plus x over x minus 1. And the oblique asymptote is x plus 2. And we just need to solve. And so in order to do that, we can clear out the fractions. We can multiply by x minus 1 on both sides. And the x minus 1 cancels on the left side, and we're just left with x squared plus x. And on the right side, we can multiply this out and get x squared plus 2x minus x is going to be plus x minus 2. And then we can subtract x squared from both sides, and they cancel. We can subtract x from both sides, and they cancel. And we're just left with 0 equals negative 2. And since that's a contradiction, since that's never true, we know there's no solution. And we know that h of x does not cross the oblique asymptote. Okay, so let's go on and make a sign diagram. Let's see. Remember, we use the x-intercepts, and we also use the vertical asymptotes to create the intervals on the sign diagram. So we have a vertical asymptote at 1, x-intercepts at 0 and negative 1. So from least to greatest, negative 1, and then 0, and then 1. So we'll start at negative infinity and go up to negative 1, then negative 1 to 0, 0 to 1, and 1 to infinity. Okay, test values to the left of negative 1 is negative 2. Between negative 1 and 0 is negative 1/2. Between 0 and 1 is positive 1/2. And then greater than 1, we can just use 2. And then we want to check the sign of the function on each of those intervals. And so the function, we should use the factored form, the x times x plus 1 in the numerator, x minus 1 in the denominator. X times x plus 1 in the numerator, x minus 1 in the denominator. And so let's see here, if we plug in negative 2, we get negative 2, which is a negative number, multiplied by negative 2 plus 1, which is negative 1. It's another negative. Negative 2 minus 1 is a negative. All those three negatives together, multiplied and divided, make a negative. Make a negative. And so we can say that h of x is below the x-axis on this interval. And then we can go on, we can use negative 1/2, and we can get factors that are negative, positive, and negative, which gives us a positive sign, and so we're above the x-axis. And then 1/2 gives us positive, positive, and negative, so that would be negative below the x-axis. And the last one should be all positive factors, meaning that the sign is positive and the function is above the x-axis. Okay, so we want to put all this together to sketch the graph. So let's see here. I think we can fit it in here to the side. We'll start with x and y axes. And then we'll fill in the asymptotes. So there was a vertical asymptote at 1, and so we can make a scale Just need one tick mark so far out to the right of the origin, and we can label our vertical asymptote at x equals 1. And then there was an oblique asymptote at x plus 2, y equals x plus 2, and so we want to graph that. We have to be a little bit careful about that. We just need to graph the line. It shouldn't be too bad. The y-intercept is at 2. And then we need to go over 1 and up 1. So that should be about right there. That would be the point at 1, 3. And we could also go down 2 and back 2. And we could find the x-intercept of the asymptote at -2. So let's see here. Let's bring that point down just a little bit. And then let's draw a dashed line through those points. Okay, so there's an oblique asymptote at y equals x plus 2. And what else do we know? We know there is an x-intercept at -1 and another x-intercept at 0, and there's a y-intercept at 0. These are things that we found earlier in the problem. We also know that the function does not cross the oblique asymptote, so we'll make use of that fact here in a minute. So we're ready to go ahead and start to sketch the curve, and we're just going to use the sign diagram and figure out where this thing goes. So we go from usually we go from left to right, and work our way across the graph. At the left end of the graph, we have this oblique asymptote. This means that the graph must approach the oblique asymptote. And so there are only two ways to do it. It would be either above or below the oblique asymptote. And which is it? Well, that's a little hard to tell. If we look at the sign diagram, all it tells us is that we're below the x-axis, and of course both of these arrows are below the x-axis, so that doesn't help. But if we think about where the curve has to go next, then we should be able to figure it out. Where does the curve go next? Well, it goes through the x-intercept here, and then the next x-intercept here. And so how does it get there? Well, it doesn't cross the oblique asymptote. So it can't be this curve above. It has to be this curve below. It has to be this guy right here so that we can connect it up with the x-intercepts and come back to and then approach the vertical asymptote. So I'm going to erase that and draw it a little bit better. I'm going to do something like that. And notice that I'm below the x-axis to the left of -1. And then I went above the x-axis from -1 to 0, just barely, just a little bit, but that's enough. That's good enough. And then from 0 to 1, I'm back below the x-axis, and of course I'm approaching the vertical asymptote, so I must be shooting down, pointing down just to the left of the vertical asymptote. We can pick up on the other side of 1, and we know that h of x is above the x-axis, so there were two possibilities, right? We can either shoot up on the other side or down on the other side. But since the function is above the x-axis, we must be using this arrow up here and not this arrow down here. And then where does the arrow go? Well, it doesn't approach it doesn't cross the the oblique asymptote. We know that. So it must just turn and go with the oblique asymptote, approach the oblique asymptote as we go out to the right end of the graph. And our graph is complete, and we're done with the problem.